Hi, welcome to another video of the Organic Chemistry Lab series. In this video, we will talk about the synthesis of alkyl halides from alcohols. Conversion of alcohols into alkyl halides is an example of a nucleophilic substitution reaction. In this reaction, alkyl halides can be prepared from alcohols via the nucleophilic substitution reaction, either using HX or using NaX plus H2SO4. So in this reaction, an alcohol in the presence of HX or NaX plus H2SO4 will be converted into an alkyl halide plus water. So this is a substitution reaction because the OH group is substituted by X. Now, what's the difference between using HX and NaX plus H2SO4? HX, which is like HCl or HBr, are all kinds or types of toxic halo acid gases. That's why, to avoid using these toxic gases in the lab, we can use this alternative method, which is using NaX plus H2SO4. Now, this is going to lead to the formation of HX plus NaHSO4 minus. Using this method will help us to avoid using the toxic gases, and in fact, HX will be generated in situ. So it will be generated inside the reaction flask instead of adding it from the outside. So this is the advantage of using NaX plus H2SO4 instead of using HX in this reaction. Now, depending on the type of alcohol, the mechanism could be either SN2, and this is for primary alcohols. For secondary and for tertiary alcohols, the mechanism of conversion of alcohols into alkyl halides will be an SN1 mechanism. This is an example of the formation or the conversion of butanol, one butanol into one bromobutane using NABR and H2SO4. Again, those two are mixed together so that HBr can be formed in situ, and then the formed HBr is used to replace the OH group by ABr in this reaction. This reaction will be usually run in a distillation setup. Again, we use a distillation setup so that we can collect the products on the other side in the receiving flask. Usually an excess amount of the acid is used to shift the equilibrium to the right. Again, acids usually appear on the left side of the equation. So when I add or increase the amount of acid, this is going to shift the equilibrium to the right according to Le Chatelier principle. The collected alkyl halides usually will have higher density than alcohols. So usually, if you have two layers, the alcohol will be the top layer and the alkyl halide will be the bottom layer. Now, how can we separate the alcohol from the alkyl halide? We can do this using acids. So if I have a mixture of an alcohol and an alkyl halide, when I add an acid such as H2SO4, this is going to protonate the alcohol. Once the alcohol is protonated, it will be a more polar compound, and that's why it will move to the aqueous layer. Whereas this acid will not react with the alkyl halide, and that's why upon extraction with acid, the alcohol will go or will move to the aqueous layer, whereas the alkyl halide will stay in the organic layer. And this is one way of separating the alcohol from the alkyl halide, because usually the alcohol and the alkyl halide will have a very close boiling points, so we cannot usually separate them by distillation. And using this acid extraction could be one of the methods for separating them. Now, what about the mechanism? We are going to talk about both mechanisms, the SN2 mechanism and the SN1 mechanism. Again, if my alcohol is a primary alcohol, it's going to react with HX via an SN2 mechanism to give us the corresponding alkyl halide. So how does this happen? The first step is protonation. So the alcohol abstracts a hydrogen from the acid, and this leads to the formation of a protonated alcohol plus X minus. Since this is an SN2 mechanism, X minus directly attacks here, OH leaves, and this gives the corresponding alkyl halide plus H2O. So this is the SN2 mechanism. It's a direct displacement mechanism. So the first step is protonation step, which is used just to convert the OH group into a good leaving group and to generate the nucleophile, which is in this case X minus. Once a nucleophile is generated, it attacks and H2O leaves, and now H2O is called or is known to be the leaving group in this reaction. However, if the alcohol is actually primary or secondary, then it may react by an SN1 mechanism. And then the product is going to be the same thing, however, the mechanism will look different, but the first step is always the same. So the alcohol attacks HX. This is again the protonation step. Once the protonated oxygen is formed, now X minus is not going to attack directly. It's going to wait for some time. This protonated alcohol will dissociate. This is a slow step, and it will give a carbocation plus H2O. Now the carbocation, which is the intermediate, will be attacked by the nucleophile, and this will lead to the formation of the product. So as we can see here, the first step is the same. It's a protonation step. However, instead of having a direct displacement by X minus, attack by X minus to displace OH2, X minus waits for some time, H2O leaves, giving a carbocation intermediate, and the carbocation intermediate is attacked by X minus, and this leads to the formation of the product. And this is the SN1 mechanism for the conversion of alcohols into alkyl halides. Thank you.